So this session is about attacking Kubernetes, and it's related to Kubernetes track. Actually, Kubernetes, as you know, it's like any application in our system. So this application is gonna be hacked or gonna be target for hackers. In this session, we will talk firstly about Kubernetes state in infrastructure, how Kubernetes integrated with our layers. Then we will talk about Kubernetes security states with infrastructure layers as well, how it affects the security. Then we will take some interesting CVEs and vulnerabilities with a history of Kubernetes. Okay, then we will take an example about vulnerability that actually is just exposed before 1 week related to network. Then we will talk about hacking and black box penetration testing steps, which for specific it's for Kubernetes. And lastly, I will talk about how to secure your Kubernetes cluster. The first question I want to ask you guys, why Kubernetes is target for hackers?
Because our applications there.
Yep. And?
Just never attack vector.
Sorry?
It's just never attack vector.
Yes. Yeah, actually, the answer is not different from any question why hacker want to hack, even Kubernetes or anything else. But why Kubernetes? Because at these days, Kubernetes has accelerated to be the first tool to use and to accelerate to deploy our containers. And that means lots of companies use Kubernetes, huge company with reputation. And it means that we have a huge solution is already deployed in GitHub with different build tool and already used inside Kubernetes, which make the Kubernetes attractive target for hackers. Not only for steal information itself, but maybe they have other targets with their minds. So firstly, we have to just think from the hacker side why they want to hack Kubernetes. Sometimes the hackers only want to just make your services down. And the last reason that to make money, how the hackers could make money from hacking Kubernetes, just because they can utilize the resources, CPU, memory, from the nodes to, for example, use it for create bitcoins and make money from that, or just to create ransomware viruses and then enforce the company later on to pay for them to recover it. Second idea, actually, the difference between hackers or hacking and black box penetration testing, it's not nothing is very, very big issues. It's the difference only that the black box penetration testing, it's only legal. But hacking and black box penetration test is using same tools, same metrics, same strategy, same mentality. The only difference that penetration test is legal thing. And then the most important question for you guys, how do you think about Kubernetes security? Do you think that Kubernetes is really enhanced the security for our infrastructure or not? How many things that Kubernetes really increased or enhanced the security in our infrastructure? So all of them, you think that Kubernetes is make it the security high risk level? Okay. Now, I need just to know how you look to the Kubernetes from security side, how you think about it. The answer is yes and no. Because actually Kubernetes has some feature as really added to the security, as a good side. But on the other hand, Kubernetes also does not have some security features which make the system and infrastructure vulnerable for the hackers. Both, it depends on how DevOps and how administrator is configured your infrastructure, your cloud, your network, your Kubernetes configuration. If its configuration is very strong, very secure, it will make it very difficult to the hacker to get you hacked or to get your services down. But if your administrator don't care about the Kubernetes security or don't care about the security policy or the best practice to deploy, yeah, you will be vulnerable for the hackers. Let me please go back in time before Kubernetes. I just want to highlight for 3 points. The first thing, before Kubernetes, users, we have only one door, actually, or 2 doors to our infrastructure from outside. The first one from users, which actually access the apps, and the node, which really we access it via SSH. But in Kubernetes, now we have multiple doors. We have users access the app, but the app actually connected with the containers. But also we have users access the kube proxy. We have developers, admin, access API servers. We have etcd, which the service is already exposed remotely outside the cluster network. So the number of doors is increased now for the hacker if we want to look to the infrastructure as a house for our solutions. The second difference, the way how the node is communicate with each other before Kubernetes, this is only we have VPN network or private network or SSH channel or some secure channel. Now in Kubernetes, the node, even master node with worker or worker with worker. So master node with worker node talking via API server with a kubelet, and worker node talking with each other with a kubelet. And that means there is traffic between the nodes itself. And maybe these nodes outside the same private network, even with master node or with worker node. The second issue that not only API server and the kubelet, also kube proxy, and the API server which is talking with some services like scheduler and controller, and for sure with etcd. So we have now more than channels that transfer the traffic between the nodes. We have to keep it in mind. The third point of view from security side, the number of layers. In this infrastructure, only we have physical layer, network layer, application layer, yep. User access the app and directly they access the node directly with 3 layers. And now Kubernetes users, they somehow, we have isolated layer from the node. We have pod layer with container layer. So users talking with containers now. I mean the apps, they're talking with containers. They isolated from the node. And also the layers. We have now multiple layers added to the original layer. Cluster network layer, which has the cluster networks, Kubernetes networks, which is already integrated with the original network. And we have network, which is a communication network between the pod itself. So first layer is network. We have another network layer. Second layer inside host itself, as we have pod and container. This is a different layer, so it's duplicate host layer, duplicate network layer. The last thing, that container itself talking with Docker. I mean, it's connected with images. We can't consider it a layer, but we can consider it another door. So what Kubernetes does for security, there is some points it's really interesting for Kubernetes that added to security, like bot security policy, which let us control the privilege mode for the users, authentication and authorization, which use TLS encryption in all services, even on all transactions between API servers, kubelet, or between users and kube proxy. The role-based access control, which we use it to minimize or to make, to make the right control access for the resources. Data encryption, and finally, resource access restriction. But Kubernetes doesn't for security, for network security, because the Kubernetes actually can't control the network layer. And Kubernetes cluster can't control our hosts itself. Kubernetes can't control our physicals. So Kubernetes now under the mercy of our layers, network, application, and physical. Application, I mean runtime. The runtime application is separated layers. So for network security, host security, the vulnerability from inside container itself, and registry security for the container runtime issue. All those issues, actually, Kubernetes does not have the ability to improve it or to manipulate it or to keep it from security. It's like separated layers. That's why we should say now that if we want to talk about Kubernetes security, this is something not separated from our infrastructure. Every layer integrates with the Kubernetes, with its security, with its vulnerability. So if we have network vulnerability, it will affect the Kubernetes. If we have vulnerability in the host, it will affect the Kubernetes. And the relation, it's bidirectional. If we have vulnerability in a Kubernetes cluster, it will affect the node and the network. And the last thing, if we want to talk about the environment pipeline tool, if we use, for example, build tool like Jenkins, Octopus, Clouding, any other tool is connected as a third party with Kubernetes. Also, Kubernetes does not have the right to improve the security for those services. So, source of vulnerability is from external attack, vulnerability deployment, or from volumes itself, or any misconfiguration in the network. Let me talk about some interested or some vulnerabilities where it really was very interesting in the history of Kubernetes. RunC vulnerability, it's CVE on 2019, discovered in the February. And this vulnerability actually, it's related to application layer runtime vulnerability, which already connected with package inside Kubernetes library called RunC, which this vulnerability the description for this vulnerability that can give the RunC the ability to create another container. If the hacker gets exploit for this library, they can make another containers, they can also create another pod, they can execute a lot of commands, because RunC, like a root, take root permission inside our kernel. And this is now the relation, how the application layer vulnerability affect Kubernetes, and at the end, it's affect our hosts. Because when the hacker take advantage as a root from container is already working in the root privilege, they can control our hosts. They can control our processes. They can stop any process, which make the relation now from application layer, Kubernetes layer, has affected the host layer. This is a vulnerability location, but it's already patched, but it's good example and one from interested vulnerability. Even until now, just blogs and researches about this vulnerability. The other one, now inside kernel. This happened in 2018. And this vulnerability, spectrum and meltdown, is affected our host operating system, which is related to the kernel, which allow the hacker to read the memory. So all processes has ID and connected with the memory. So if we have, for example, containers running inside Kubernetes, they already has a process ID inside our memory, inside kernel. So in this vulnerability, the hacker could read the process ID. So if you have financial transaction between container and container, it might be compromised. This vulnerability now coming from the host one and affect Kubernetes and also affect the application layer. It's already batched and it's kernel one. It's already batched, but you need still, even the vulnerability is batched, you need as a penetration tester or as a hacker try to exploit this vulnerability. This is kernel vulnerability. Let me talk about network and the relation between network and the Kubernetes. let me talk about DNS spoofing on IRP poisoning. This vulnerability which connected with MAC address, which let the attacker control the MAC address for the router. And if any request comes to this router from node 1, for example, attacker can steal this request and convert node 1 to something else, maybe outside the node or something else. They compromise the request which comes from any node to router. They cannot switch to the right way. But this is from node to router, I mean network layer. But inside Kubernetes, we have also from pod to pod. Because as you know, each pod talking with bridge and talking with a virtual private IP. So Kubernetes, the way how network works inside the Kubernetes, that each pod also talking with a bridge and send request to kube DNS, and then the reply comes from kube DNS. But can any attacker from any pod utilize this bridge and compromise the MAC address for this bridge? And then if any request comes from this pod to this bridge, the attacker can stop it and give it malicious traffic, or send this request, send the reply from malicious traffic instead and send the request to the right way. So maybe we have demo here. I can show you. Yeah, this is like a second stage vulnerability. So the hacker should be inside the cluster network to utilize this vulnerability. I left you inside the slides some of them, and just the description that each vulnerability related to which layer: network, Kubernetes, layer itself, or app, or runtime. Let me go back to the Kubernetes doors. So as we said, we now have multiple doors. And if we want to go to this house through these doors, we have to compromise rule-based access control. And that's why we have special Kubernetes penetration tests or Blackbox penetration test. Those steps actually the same penetration test for any usual attacking or for any usual hacker. But I just will highlight each step on Kubernetes. First one, if we want to talk about footprinting or information gathering, we looking for the domain for the companies, because the domain is help us again to search about if they have certificate for Kubernetes authority. So we need to grab the domain for the company and subdomain. Actually, if you went to this website, you can find if the domain address for the company or for the service is already has Kubernetes certificates that use it with traffic transaction between the nodes inside this website. Also, if we can just locate or investigate inside GitHub, we can find some YAML files. Before this step, actually, I just in each company locate who is working in this company, if he has a GitHub account, if you has a team, and then it's helped me to go to GitHub to just search about YAML files, which code you are injecting in accounts, which services you use, what configuration file. Because in penetration testing, actually, we are draw a map about inside the infrastructure, about how Kubernetes is working, which services you have. Also, we can collect a lot of information from discovering your network, from some advertisement from the company itself. If they have any job, it's published any job in any company site. They say about the tools that they use, like Ansible, Docker, maybe Octopus, and I can just locate if these tools has vulnerabilities or batched that I can utilize it or I can exploit it. Part 2 from hacking is reconnaissance and scanning. Actually, in reconnaissance and scanning, in this step, the point of view of hacker that if we want to hack a Kubernetes, we only have two choices if I want to take access. The first one via access control or via exposed services outside the cluster. I mean, the app which is already exposed by services outside the cluster. I only have these both options. So I need to test the access control configuration, RBAC configuration, for your company. Then I need to find which the services that are already exposed outside the cluster. With multiple port scanning tool like an Nmap, so then I just can just figure out which port you have inside the company. Maybe etcd port, sometimes you can't hide it. That I can just figure out that you use etcd to hashing the traffic in the stores, for the Kubernetes component. And some Kubernetes, some services, it has already known ports that I need to discover it via port scanning tools. Shodan is the most famous one, or actually is the most used one for the Kubernetes. And if I want to go to cAdvisor, actually cAdvisor is like web interface. They expose some links about the services which already exist inside Kubernetes. Now the reconnaissance. Reconnaissance, actually, we have to try a lot of tries to just get information about your pod, about which service is exposed, HTTPS or HTTP, and not only these tries, we have a list of tries. Maybe if I can't find it in API, in some API I can find it in Matrix, maybe I can find it in Helm, maybe I can find it. So I can use multiple API requests just to collect information about the pod and about the services that you have. Not only API request for API server, actually for etcd, because already etcd is exposed to services outside. So maybe I can try with send HTTP link to etcd to just grab some information. Kubelet as well, maybe it's have read-only port, but maybe we can try it if it's maybe the admin of Kubernetes missing something. Now, part 3 is gain access. And it's gain access, actually, it has multiple vectors for Kubernetes. For example, maybe I can gain access to list your secrets, which is going to be like, I'm a king if I just could gain access to list your secrets. Then maybe I can access any resource or verb. So if your configuration in cluster or like resources all, verb all, you gift me this one. So I can just read clearly about all your resources and verb. And if I have gain access for pod creation, it will be great. So I can create malicious pod to control another bots, manipulate money deployment, or to privilege or execute some commands inside pod, which is this one. It's let me say very power privilege that I can get access inside Kubernetes. But what after that, if I gain access, what the hacker do? Actually, the hackers for Kubernetes and any other application do the same. First thing, actually, they patch security hole in your cluster. So they come to make privilege to get batch role bind. They create malicious role binds and injected it inside your clusters to just keep to keep her hands or his hands inside your clusters. So first thing, they create a role bind, malicious one, with admin privilege and inject it inside the clusters. Then the most important thing for each hacker, hide itself. So this is the most important thing. After I just put my fingerprint, I just put my hand in your cluster, I directly go to clear all logs from clusters, from pod, from infrastructure. I had myself, then maybe I can impersonate a privileged account and give service account to, and create, impersonate service account and inject it and connect it with other services. And the most important thing, if the hacker is very bad one, just to deploy backdoor through your kubelet and start to control your cluster, send your hacking tools, denial of service, so every morning will be really bad. For penetration tests, I actually recommend this tool, it's a Cube Hunter, or a Cube Hunt, it's from Aqua. You can use this tool and you can act like a hacker with this tool inside your cluster. And then you can just try a vulnerability which already exposed in the CVEs if it exists or not. You can list or create API requests for your services just to see if you already have exposed services outside or not. For the security, actually security, as I said, not only belong to Kubernetes itself, it's also belong to the infrastructure, the host, and the Kubernetes. So we need to keep the internal security inside the Kubernetes with all those options, from authorization, authentication, and follow the network policy, the secrets. For container runtime, actually, you have to run some vulnerability management or vulnerability scanning tool for the Docker image before you deploy your app. It's like a separated step to run scanning tool for Docker image to be sure that the app itself is secure. Actually, it will be recommended if you can separate the clusters for your environment from production, development, and staging. For Docker image also, it's recommended to use the minimal base. And for the pod, actually, this is a very important thing to enforce resource quota, because this one which related to the pod resources. And if you don't determine resource quota, it means that you give the pod a lot of resources. And if the denial of service come to the pod from outside, from the app, maybe it can make the whole node down. But if you give quota, resources quota, you determine it for the pod, maybe you can, or for sure, you will prevent denial of service at least for the rest of pods if this pod exactly get down. It's like you just try to make sandboxing for another pods to keep it from utilize their resources. Namespaces is very important. Actually, for service account, the default setup for Kubernetes that use default service account, you need to change it to make custom service account. Also, authorization, when you connect the role binding with services, actually you need to determine the resource one, the verb for these resources, and actually you have to connect it with role binding in right way to determine the user and the rights only that they have inside the role binding. I just recommend some security tool to scan Docker images or to just look for Docker images vulnerability like Clear Chorus or Docker scanning tool or Aqua or Twistlock. But maybe Twistlock it's paid one, it's not free one. You can use Kubernetes Auto Analyzer also as a kube bench to just make a look about the bench or the security for Kubernetes. Actually, I have to tell you that the most important thing for me It's monitoring and monitoring and monitoring. Keep your logs for infrastructure, logs for application, and logs for Kubernetes itself. And monitoring, it will be appreciated for all admin if you make a monitoring in all levels, not only in Kubernetes. Even if you can monitor your clouding resources, your infrastructure, your CPU, your memory, anything that you just can feel that it's like the behavior, it's like no abnormal behavior that may be indication that you are get hacked. Thank you.